There is a machine being designed right now that could let a telescope on Earth's surface see a planet a billion times fainter than the star trying to hide it. And if it works, it could show us the first real, direct picture of another Earth. Not a simulation. Not an artist's impression. An actual photon of light that bounced off an alien world and traveled to a mirror in Chile. Here's the problem scientists have been fighting for decades. Stars are blindingly bright. Rocky planets like ours are small, cold, and reflect almost no light. Trying to photograph an Earth-like planet next to its star is like trying to photograph a firefly sitting 1 inch from a lighthouse beam, from thousands of miles away. Even NASA's James Webb Space Telescope, with its incredible infrared camera, cannot do this. Even the upcoming Roman Space Telescope's coronagraph instrument, built specifically to block starlight, still can't directly image a true Earth-sized rocky world. The glare simply wins. So a NASA-led team has proposed something that sounds almost too strange to be real. Instead of building one enormous, impossibly expensive space telescope to solve this problem alone, they want to launch a giant shade into space, a literal shadow-making machine, and pair it with the biggest ground-based telescopes humanity has ever built. They're calling it the Hybrid Observatory for Earth-like Exoplanets, or HOE. Picture this: roughly 175,000 kilometers from Earth, nearly halfway to the moon, a spacecraft unfolds into an enormous flower-shaped structure. 48 individual petals, each about 24.5 meters long, extending out from a central disk, 50 meters wide. It looks almost like something out of science fiction, but it's an engineered optical instrument. That structure then positions itself with extreme precision, accurate to within 6 meters, directly between a distant star and a telescope on Earth's surface. Using tiny thrusters, likely powered by hot hydrogen gas, it holds that position, casting what the research team literally calls a perfect shadow across the telescope's mirror. Starlight gets blocked before it even reaches our atmosphere. What's left over, the faint reflected light bouncing off any planets orbiting that star, can now be seen. This isn't a rough concept sketched on a whiteboard. It's outlined in detail in a 2026 paper published in the journal Nature Astronomy, co-authored by Nobel laureate John Mather, the same scientist behind the James Webb Space Telescope, along with 2019 Nobel laureate Michelle Mayer, who helped discover the very first exoplanet ever confirmed around a sun-like star. When people like this attach their names to something, the world tends to pay attention. The plan is for this starshade to work in tandem first with the European Southern Observatory's extremely large telescope, currently under construction in northern Chile, expected to achieve first light by late 2030. That telescope alone will be the largest optical telescope ever built on Earth. Combine it with a perfectly engineered orbital shadow, and according to the research team, you get something remarkable: the potential to detect an Earth-like planet within the very first minute of observation. 1 minute. To potentially confirm the existence of another rocky world, tens of trillions of kilometers away. And this isn't limited to just spotting a planet exists. The entire purpose of direct imaging is to actually study the light coming off these worlds, to break it apart and read its chemical fingerprint. That's how scientists search for the building blocks of life itself. Vladimir Arapetyan, a senior astrophysicist at NASA's Goddard Space Flight Center and a lead member of the HOE project, has a very specific target in mind. He wants to search for auroras. Yes, auroras, like the northern lights, but on planets orbiting other stars entirely. Specifically, he's hunting for young, active stars that flare frequently enough to trigger auroras on nearby rocky planets. If astronomers can detect the spectral signatures of red and green light, the same colors you'd see in Earth's own aurora, it could mean that planet's atmosphere contains nitrogen and oxygen, two of the most important ingredients associated with a life-supporting world. Let that sink in for a second. we could potentially detect signs pointing toward a breathable atmosphere on a planet we've never physically visited, using reflected starlight bounced off a rocky world 20 light-years away. 20 light-years might sound impossibly far, and in human terms, it is. But in cosmic terms, that's essentially our galactic backyard. The HOE concept is specifically designed to study planetary systems within that 20 light-year radius, nearby solar systems, close enough that if there's something out there resembling early or primitive life, this could be one of the tools that actually finds it. Now here's where a lot of people expect the twist, the part where this turns out to cost hundreds of billions of dollars and take 50 years to build. That's the usual story with next-generation space telescopes. But according to Exoplanets, the estimated cost for this starshade sits in the billion-dollar range. Not trillions, not hundreds of billions, roughly the cost of a single ambitious space mission, dramatically cheaper than building an entirely new flagship space telescope with the imaging power required to do this alone. Part of what makes that possible is the engineering. The final starshade design is expected to use an inflatable structure, keeping the total launch mass under 1,500 kilograms. That means it could be folded down and launched using a standard rocket, rather than requiring some record-breaking, custom-built heavy-lift vehicle. The project has already applied for Phase B funding through NASA's Innovative Advanced Concepts Program, known as NIAC, with the team hoping for approval by 2027. It's still an early-stage concept, not yet a fully greenlit, funded flight mission. But the underlying physics, the orbital mechanics, and the optical engineering have now been laid out in a peer-reviewed scientific paper, backed by researchers with Nobel Prizes attached to their names. As Exoplanets put it, for decades the starshade was treated as a beautiful, almost impossible dream. Something theoretically elegant but practically unreachable. Today, through this NASA-funded research, that dream is edging toward becoming an actual, buildable reality. Think about where this could lead. If HOE, or something built on the same principle, eventually flies, we may be standing at the edge of the moment when humanity stops merely inferring the existence of other Earth-like worlds through indirect wobbles and shadows, and instead starts actually seeing them. Real photons, real reflected light, real images of planetary systems that might harbor the same ingredients that allowed life to emerge here. We've found thousands of exoplanets over the past 3 decades, but only a tiny fraction, around 1.5%, have ever been directly imaged because the light from their stars simply overwhelms them. This starshade concept is aimed squarely at solving that exact problem, for the exact kind of planets we care about most: small, rocky, potentially habitable worlds like our own. So here's the real question this raises. If scientists succeed in directly imaging a rocky planet with signs of oxygen and nitrogen in its atmosphere within the next decade, are we actually ready, as a species, for what that discovery could mean? Drop your thoughts in the comments. Would you want to know the answer, even if it changed everything we think we know about our place in the universe? And if this blew your mind, follow this page, because stories like this are only going to get bigger.